Today we are going to solve the question number 32. In a part of the 32, it is asked verify 1.7.39a and 1.7.39b for the expectation value of p and p square from the Gaussian wave packet 1.7.35. So that means we have to calculate and prove that p is equal to h cut k and expectation value of p square is equal to d square h cut square by 2d square h cut square by 2d square plus h cut square k square. So we have to prove these two expectation value where the state over which this expectation is calculated is a Gaussian wave packet, GAU Gaussian wave packet, which is x alpha is equal to alpha is the state, so the representation of this Gaussian wave packet in position k is 1 by pi to the power 1 by 4 to t exponential I kx minus x square by 2 d square. Now let us calculate. Now in this state alpha, what will be the value of expectation of momentum operator? That will be alpha p alpha. Now let us use the completeness relation of these position kits, that will minus infinity to plus infinity dx alpha x x p alpha. Here we have this will be alpha. That means, so, and from our lectures we know that previous lecture we know that this is equal to minus I h cut del x x alpha. So let us calculate it first. What is the value of del x x alpha? It will be 1 by pi to the power 1/4 root t exponential I k x minus x square by 2 t square into I k minus 2x by 2d square, which will be 1 by pi to the power 1/4 root 2 root t expectation value of exponential I kx minus x square by 2d square I k minus x by d square. So now calculate this expectation value of p. Put these things here, will get will be minus infinity to plus infinity dx. This will be 1 by pi to the power 1/4 root t exponential. It will be x alpha star is alpha's complex conjugate, that means it will be exponential minus I kx minus of x square by 2d square into multiplies, this term will be minus I cut and this del x alpha will be 1 by pi to the power 1/4 root t exponential I kx minus x square by 2t square into ik minus x by d square. The first integration will be 1 by d root pi minus infinity to plus infinity exponential minus x square by d square minus I h cut I k minus x d square. That means minus I h cut by d root pi minus infinity to plus infinity dx exponential minus x square by d square minus 1 by d square minus infinity to plus infinity dx x e to the power minus x square by d square. Now since this is an odd function, so minus infinity to plus infinity, integration of the odd function will be 0, so that means this will be 0, and this is the gamma function, that means I h cut t root pi, there will be a kik, so that means ik, and this is, if we change the variable x by d to y, that means this integration will become dx means d minus infinity to plus infinity dy e to the power minus y square. This is a gamma function, so d root pi, that means here it will be into d root pi, so this will cancel, that means h cut k. So we have seen that the expectation value of the momentum operator in a Gaussian wave packet is h cut k. Now let us calculate p square. Now similarly, the expectation value of p square can be written as minus infinity to plus infinity dx alpha x minus I h cut square del 2 del x2 x alpha. Now let us calculate this term. This will be minus h cut square minus infinity to plus infinity dx alpha x del 2 del x2 x alpha. So del x del x x alpha, that means del x of del x of this term, so that will be 1 by pi to the power 1/4 root t exponential I kx minus x square 2t square into ik minus x d square. So this will give 1 by pi to the power 1/4 root t. If we differentiate this, it will give exponential I kx minus x square by 2d square, and when we differentiate it, first you will get back here, and then we will get similar term ik minus x by d square with square plus this term, and it differentiation this, so that means exponential I kx minus x square by d square into minus 1 by d square. So is actually 1 by pi to the power 1/4 root t minus k square minus minus 2I kx by d square plus x square d to the power 4 minus 1 by d square exponential I kx minus x square by d square. Now if we put this value here, we will get minus h cut square by d root pi minus infinity to plus infinity dx minus k square minus 1 by d square exponential of x square by d square. They help to x square by d square. Since we multiply alpha x, means x alpha star with this, so that's why minus x square by d. And there is another term plus h cut square by d root pi minus infinity to plus infinity dx minus 2I kx by d square exponential minus x square by d square. This will be 0 again, since it's a odd integral. This will be 0, and the last term will be plus h cut square by root pi d root pi minus infinity to plus infinity x square d to the power 4 exponential minus x square by d square. So the first integration give, as we have seen previously, d root pi, it will give minus k square minus 1 by d square into d root pi. This integration will give d root pi. This will be 0, and this integration, let us see the what is the value of this integration. This integration will be 1 by d square minus infinity to plus infinity dx x square by d square e to the power minus x square by d square. If we take x by d equal to y, that means this integral will become d minus infinity to plus infinity dy y square e to the power minus y square, which means this integration is gamma 3 by 2, and gamma 3 by 2 means half root pi. That means here h cut square by d root pi minus k square minus 1 by d square plus d root pi plus 1 by d square, it will be d root pi by 2. That means here h cut square k square, and if we add these two terms, we will get plus, we will get minus, this will be d square, 2d square, that will be plus h cut square by d square minus h cut square by 2d square, that will be h cut square k square plus h cut square by 2d square. So we have seen that the expectation value of p square is actually is this relation in the Gaussian ray packet. So we have solved the A part of the question 32. Now let us see the part B of the question 32. Here it is asked, evaluate the expectation value of p and p square using momentum space eigenfunction. So first we have to rewrite this Gaussian wave packet in momentum space. So how can we do so? So let us see that the quick part. We know x alpha, the position representation. Now we have to calculate from here the momentum representation. So let us see that. So we have to calculate p alpha. P is the eigencase of the momentum operator. So, and this will be the momentum representation of this wave function alpha, of the state alpha. It will be now. Let us again use the completeness relation x of x, that means x alpha dx minus infinity to plus infinity, since this dx is equal to unit identity operator, since x eigengates are complete eigengates, that means these can be written as in this form. So that means this will be minus infinity to plus infinity, and we know that px is equal to, we know that xp is equal to 1 by root over 2 pi h cut exponential plus I px by h cut. So that means px is the complex conjugate of the xp, that means it will be 1 by px 1 by root over 2 pi h cut into the power minus I px I h cut, and here xp is same as previous, that means here we will get xp will be 1 by root over of 2 pi h cut minus infinity to plus infinity dx into the power I px by h cut, and x alpha is exponential of I kx minus x square by 2t square. So it will be 1 by root 2 pi h cut into 1 by pi to the power 1/4 root t minus infinity to plus infinity. This term will be here, this term is also here that I missed, dx exponential I h cut k minus p x by h cut minus x square by 2t square. Now let us calculate what will be the momentum representation of the state. So first let us calculate that. It will be so 1 by root over 2 pi h cut 1 by pi to the power 1 by 4 root t minus infinity to plus infinity dx exponential of, take minus outside, and x by root 2d its square and minus 2x by root 2d into I h cut k minus p by root 2t, sorry, by we rewrite this term like this, x by root 2d. So we have to here again take x whereby there will be no root 2d, so we have to take one root 2d in the upper side, d root 2 root 2 means 2, root 2 into root 2 times root 2 is 2, that will cancel, d and d cancel, and finally it will left I h cut p x. So we rewrite this term. Now add some term here to make it square, so let add this term plus I h cut k minus p into d by root 2 h cut its square. So we have to again subtract this term, that means multiplies exponential, this is minus, so plus I h cut k minus p into d by root 2 h cut its square. So that means here we can write it as 1 by root pi h cut 1 by pi to the power 1/4 root t times exponential p minus p minus h cut k square t square by 2 h cut square. So write it here, times minus infinity to plus infinity dx exponential of minus x by root 2d minus I h cut k minus p d by root 2 h cut its square. And what will be the value of this integration? Now if we change the variable x by root 2d is equal to y, then these minus these also, so minus I h cut k minus p d by root 2 h cut is equal to y, that means dy equal to dy will be x dx by root 2d. So if we rewrite, this integration will become root 2t minus infinity to plus infinity dy e to the power minus y square, that will be root 2t root pi. So that means our this final result will be 1 by root over 2 pi h cut into root 2 pi times t by pi to the power 1/4 root t exponential of minus p minus h cut k d by h cut its square. So now this is the momentum representation of the wave gate. So we can further simplify this. This is root t by h cut pi to the power 1/4 exponential minus p minus h cut k t pi h cut h square. Now let us calculate the expectation value. That means in this state, so expectation value will be again alpha p alpha. Now it will be minus infinity to plus infinity tp prime alpha p prime p prime p p p alpha. Here again we use the completeness relation of the momentum eigengates. So this will become minus infinity to plus infinity dp alpha p prime. Since this is eigencase of the momentum operator, that means, and p prime means delta p prime p prime p alpha. So that means it will be minus infinity to plus infinity dp alpha p prime p prime. Since we integrate it out, since the integration only non-zero for when p prime is equal to p, so that means this p and p alpha. Now let us calculate what is the expectation value. So that will be minus infinity to plus infinity dp. This is d by h cut. Since p alpha, this is p alpha, so and alpha p means its complex conjugate. That means it will be, if multiply these two, t by h cut into 1 by root pi exponential of minus p minus h cut k square t square by h cut square into p. There is a 2 h cut square, there will be also 2 h cut square. When we multiply these two terms, alpha x alpha p and its complex conjugate alpha p star, that means this will become square of alpha p. Since alpha p is real, so that means alpha p square, so that way 2 got cancel. That means this will, now if we integrate it, it will be by root pi t by h cut minus infinity to plus infinity dp p exponential of minus p minus h cut k h square t square h by h cut square. Now change the variable p to p prime, which will be p prime is equal to p minus h cut k into d by h cut. That means p will be h cut p prime by t minus h plus h cut k, which is tp means h cut by t tp prime. So if we put the value here, we will get 1 by root pi t by h cut minus infinity to plus infinity dp means h cut by t p prime. This p will be h cut by t p prime plus h cut by k exponential minus p prime square. And the first term, since this integral becomes odd, so this first term will contribute nothing, that means it becomes 0, so only contribute h cut by k 1 by root pi. The h cut will cancel out, that means minus into plus infinity h cut k dp prime exponential of minus p prime square. And this is a gamma half means root pi 1 by root pi h cut k into root pi, so that means h cut k. So we have again seen that the expectation value of this wave function in momentum space also h cut k. Now let us see what is the expectation value of the p square in momentum space. So to do so, this p square means similarly we can calculate this. This will be minus h cut square minus infinity to plus infinity dp alpha p square p alpha. So let us calculate. It will be h cut square into h cut square into what is the value of alpha p? Alpha p value of alpha is 1 by root 2 pi h cut 1 by, this will be alpha p, so there will be a 2, right? So that means will be d by h cut pi to the power half d by h cut into 1 by pi to the power half 1 by pi to the power half exponential minus infinity to plus infinity dp p square e to the power exponential minus p minus h cut k by h cut t its square. So that means minus h cut square into t by h cut into 1 by root pi, and if we change the variable, what we'll get? Variable change, so we will get h cut by t with p prime is equal to p minus h cut k by h cut into d, that means minus infinity to plus infinity minus infinity to plus infinity dp prime, p will be h cut p prime by t plus h cut k its square, right? H cut p plus by t plus h cut square exponential of minus p prime square. This will cancel, that is minus h cut square into 1 by root pi into minus infinity to plus infinity h cut square by t square p prime is square exponential minus p prime square plus h cut 2h cut square k by d minus infinity to plus infinity p prime exponential minus p prime square. This will be 0 or since identical, and last term will be h cut k h cut square k square minus infinity to plus infinity dp prime exponential of minus p prime square. Now here we have did a mistake, that means here we multiply with extra h minus h cut square, so it will not be there, it will not be there, it will not be there. So this is root pi 1 by, this means gamma half, that will be h cut square by d square, and this dp prime square is gamma 3 by 2, that means half gamma half root pi, and this will be 0 and this will be h cut square k square, this will be root pi, that means h cut square k square plus h cut square by t square. So from here we again see that the expectation value of p square using the momentum space wave function is also h cut square by 2d square h cut square by k square, h cut square k square plus h cut square by 2d square. So we have solved the question 32. Now we'll solve the question number 33. In question number 33, it is asked that prove that p prime x alpha is equal to I h cut del p prime alpha. We have seen previously the position representation of the momentum operator, Now it is asked to show what is the momentum representation of the position operator. We have to calculate this, so let us see what it is. In I, by using the relation, this relation, that means position representation of the momentum, we have to calculate p prime x alpha. So to do so, let us use the completeness relation of momentum operator, that means integration minus infinity to plus infinity dp p is identity operator. So let us use it here, minus infinity to plus infinity dp p prime x p alpha. Now let us calculate what is the value of this, that means p prime x p. To see what is the value, let us use the completeness relation of the position eigencase, minus infinity to plus infinity t x tx prime p prime x prime x prime x x x p is equal to minus infinity to plus infinity dx dx prime. This is 1 by root over of 2 pi h cut e to the power minus I p prime x prime by h cut. This will be x times x prime x, that will be delta x prime x, since x prime, these eigencates are orthonormal, that means x delta prime, and this will be e to the power I p x by h cut by root over 2 pi h cut. So this means 1 by root over 2 pi h cut minus infinity to plus infinity dx e to the power x e to the power minus I h cut p plus h cut p minus p prime x. Now what is value? Now let us check. This is actually root. There will be no root. 1 by 2 pi h cut. 1 by 2 pi h cut. These things. So we know that the form of delta p minus p prime. We know that delta p minus p prime is p minus p prime is 1 by root over 2 pi h cut minus infinity to plus infinity dx e to the power minus I p minus p prime by h cut x. And if we integrate this with respect, differentiate it with respect to del p, we will get del p of delta p minus p prime, that will be 1 by 2 pi h cut minus infinity to plus infinity dx del p of e to the power minus I p minus p prime x by h cut. So this will be 1 by 2 pi h cut minus infinity to plus infinity dx. If we integrate differentiate it, we will get here I x by h cut. This will del p. There difference we have already differentiated, so there will be no differentiation. That means it will be to the power I p minus p prime x by h cut. That means minus infinity to plus infinity dx x e to the power minus I plus I p minus p prime x by h cut is equal to minus I h cut 1 by 2 pi h cut is equal to I h cut del p delta p minus p prime. Now use this relation here in this differentiation, in this integration. What we'll get? We'll get p prime x alpha is equal to minus infinity to plus infinity dp, and we know that p prime xp means p prime xp actually means p prime xp means this integration, and this integration means minus I h cut del p delta p prime delta p prime, and there will be a p alpha. Now let us do this integration with the by parts. We will get this will be minus I h cut. First term will be delta p minus p prime. We integrate this term and differentiate that term p alpha, and since alpha is a wave function, it should be goes to 0 due to this alpha should goes to 0 at minus infinity to plus infinity. From that it is actually 0, and the second term will be plus I h cut minus infinity to plus infinity dp. There will be delta p minus p prime and del p of p alpha, that means I h cut. This will be p prime, integration will give del del prime p prime alpha, and here we have used p alpha at alpha infinity is equal to 0 and plus infinity, and p minus infinity is equal to 0. Since we have assumed that alpha is a wave function, so it should goes to 0 at plus infinity and minus infinity to remain normalized, normalized. So that is it. So we have proved that p prime x alpha is equal to I h cut p prime alpha. Now let do the second part, b, where we have to ask to beta x alpha, what is the value of beta x alpha in the second part, beta x alpha. Let us see that. That will be integration dp beta p x alpha, and we have seen that what is it is minus infinity to plus infinity dp. This actually wave function, it is actually p beta x star, and p beta means the wave function represent in momentum space. That means dp, it actually, that means phi, if we take this actually p beta is equal to phi beta function of p, that means this actually phi beta star p, phi beta star p, and this is del p I h cut del p alpha. That means minus infinity to plus infinity dp, and this also alpha phi beta star p I h cut del p, and this is also a wave function which phi alpha p. So it is asked in the question 2. We have solved the question 2. Now see the part B of the question 33. Here it is asked, what is the physical significance of exponential I x theta by h cut, where x is Poisson operator and theta is some number with dimension of momentum. Justify your answer. So B part is, what is the physical significance of this operator exponential I x theta by h cut. So do so. Let us check the commutation relation between momentum and this function x theta and h cut. And from our previous problems, we know that this actually equal to minus I h cut del x exponential of I x theta by h cut. That means I h cut I theta by h cut exponential of I x theta by h cut. It will be plus theta exponential of I x theta by h cut. Now suppose P is an eigencase of the momentum operator, and that means P will be P. Now operate this eigencase with the given operator exponential I x theta by h cut. Let's see what it does. It will be, and now let us see, is it remain, is it again an eigengate of the p momentum operator or not? If it remain the eigengates of the momentum operator, then what is the eigenvalue corresponding the transform state? Let us see. So if you operate p momentum operator in the state exponential of I x theta by h cut p. So now let us use the commutation relation. That means x exponential will be this is actually p exponential I x theta by h cut minus p minus exponential I x theta by h cut p. That means we will get exponential I x theta by h cut p plus theta exponential I x theta by h cut p. So theta by h cut operating on p. If it operate on p, it will give same thing, and this will give p. That means p plus theta to exponential of I x theta by h cut into p. So this state is an eigengates of the momentum operator, but the eigenvalue shifted by amount theta. That means this operator actually translate the momentum by an amount theta. So this operator basically a translation operator in the momentum space. Translation operator in the momentum state. Translation operator in the momentum state. So we have solved the question number part B of the question number 33.